all on. That's going to be no. They can work simultaneously.
So welcome to the panel discussion. First of all, so everybody sees the very distinguished panel here, and I will introduce the discussion in a moment, but Sergiu would like to say something about a technical issue for 2 minutes first.
Yes. So I asked yesterday a question, and a few people that I respect said it's a very good question, and I didn't explain it and nobody understood it. So I want to repeat the question, and here is the question. What is the computational complexity of computing correlated equilibrium, finding some correlated equilibrium in an n-person game? Okay? Now let me explain why I'm asking this strange question. Okay? So take an n-person game where, say, every player has just 2 actions to make it very simple. Okay? So the number of unknowns, so the number of cells in the game is 2 to the power n. 2 to the power, oh, hello? 2 to the power, 2 to the power, 2 to the power. Doesn't work. The 2 is okay, the exponent, it disappears, I think. It all becomes polynomial. Anytime I say to the power, it's gone. Okay, so, okay, so the number of cells is 2 to the power n, so the number of unknowns is 2 to the power n. The number, so there is one constraint, which is the sum of all probabilities being 1, okay? And then there are 2, for each player has just 2 inequalities, so there are 2 times n inequalities. And we are looking for a feasible point, so it's a linear programming problem with 2 to the power n unknowns, and n or 2n doesn't matter, inequalities, okay? Now, for such a problem, we know how to solve it in polynomial time, polynomial in 2 to the power n, okay? Which means exponential in n. Question, can one do it? So the data of the problem, by the way, the data of the problem is in each cell, the payoff of each player. So in each cell, I have n numbers. So I have 2 to the power n times n numbers. That's the data. So the data is exponential in n. Nevertheless, nobody knows how to prove yet that one cannot solve this problem less than exponential in n number of operations. Okay? Now, why would... Sorry? Right. Now, why would I even think that this could be possible? So first of all, for any linear programming problem like this, there are solutions whose size is 2n. Namely, only 2n unknowns are non-zero, everything else is 0. To check something like this, since you only have 2n inequalities, you only check something like 2n squared or something, polynomial number of entries into the matrix. So to check a correlated equilibrium, you don't have to look at the whole data. It's enough to look at n squared, order of n squared number of entries. No problem. You know what? For you, n cubed, just to make sure I didn't. But anyway, polynomial, okay? Now, that's true of any linear programming problem of this size. So I've said nothing special. But there is one more thing. There are approximation algorithms, regret matching, various things like this, that can get you with probability 1 minus epsilon, within time like 1 over epsilon squared or cubed or whatever, an epsilon correlated equilibrium. So you can get an approximate solution to this linear programming problem. In the number of operations that you need to do there is, again, polynomial in n. So with complexity that is polynomial in n, you can get an epsilon approximation with probability 1 minus epsilon. That's something that, as far as I've been told, is not known to be true for linear programming problems, general problems like this. So this may well be a special linear programming problem that has specific structure. In fact, this specific structure has been used for various things, like the results of Tim and Christos and so on, and what we heard the talk yesterday, right? Forgot. Sounds like a week ago. Yeah. Okay, so that's a question. Either prove that this problem is just as difficult as a general linear programming problem of this size, which means it's exponential in n, or show that it's simpler. Okay, that's it.
Thank you. Okay, so I just want to say a couple of things before I'll move it to the panel here. So I want to recall a fascinating workshop that Noam and I did In 2001 October, this was the first workshop in algorithmic game theory, and we held it at Dimax. That was just 2 months before this movie was supposed to come out, Beautiful Mind. The reason I talk about the movie is that 2 days before the workshop, John Nash decided he wanted to attend the workshop. So we put him on the panel, and on the day of the panel, all the computer scientists from New York, New Jersey ended up in that one hall. And it was really an event, but it was also very enlightening because the people mentioned many, many things. I know I learned more from the panelists there than from the talks, actually, truly. So in any case, there was everybody felt like a pioneer in that time because we knew there was a field coming up which could be alive for a long time. And at that point, also were established some of the important questions of the field, which have definitely contributed to giving a direction over these 10 years. And it looks like many of those problems are now solved, or at least to a great extent understood or reduced to some very hard questions in complexity theory. So certainly Nash equilibrium, market equilibrium are like that. And just to mention a very provocative statement of Noam's, price of anarchy is dead. And I'm sure there's somebody on this panel who's going to take that up very seriously. From Noam's blog, that the price of anarchy is dead. In any case, so we'll get to that soon, I'm sure. I haven't read that blog, by the way, Tim. So don't blame it on me. Somebody from here mentioned it yesterday, and I immediately recruited her to this panel. Okay. Misquotes are allowed in this panel discussion, by the way. So, okay, I just want to make one small quote-unquote vision statement before I give it to the rest of the panel, because I'm not going to speak anymore after that. And the little vision statement I want to make is that I really think the pricing of digital goods and the economy of digital goods, the economics of digital goods, is a very, very ripe subject for study. And I think, the talk that I gave, that work could have been done by an economist. There was no computer science there. But I really believe that these are goods that, of course, we computer scientists came up with, and we understand the best. And if we also understand some economics, I'm sure we can do wonders on understanding their economics. And together with the pricing of these goes a lot of other issues like dissemination, encryption, security, timestamping, limited number of copy watching, copyrights, patents, trademarks, and many of these issues have been studied by many of the people here. So there is really an area out here to dig out. So that's my little spiel. I think we have a very good lineup. Start from the end. Oh, I think Silvio is difficult to. He has something to say first.
So, can I sell you my work too?
So, deliberately, very deliberately, we put his talk tomorrow, so he cannot sell it today.
Okay, so first of all, I don't know if he speaks, in some sense can go through me and pass through. So I don't know. Certainly, we don't have such a big plenum that you mentioned like before, and I don't know about learning anything. But at least we should remember something, right? So my thing about panel is that we are at the end of the day. we are generally tired. Somebody's even jet-lagged, right? So, and it's hard to remember unless, you know, you get an aggressive... You're lecture-lagged, right? And so let's try... let's take, you know, try to be a bit controversial, right? So I want to take exception with the introduction of the 2 minutes that Sergiu eloquently put us, because let me preface by saying that I love the question. I think it's a great question. And second, I want to say that this illustrates why algorithmic game theory is the wrong name for what we are doing. Because as soon as you say algorithmic game theory, you think about questions in this form, right? So let's remember that if you go in any job place and you say, I know about computers, you make a fatal mistake. Why? Because they put you to hook wires all the time, and you don't do anything, you know, which is any fun, right? So if you tell anybody, says, I want to take whatever field is the computational aspect of your field, ha, they love you, because who wants to deal with complexity? You do, right? The computer scientist. So here is the dichotomy. We do the notions, we do the fun stuff, we tell you the definition, what to look at, but you know, is it in cube or is it in square log n? This you tell me, right? So, I think we should reject this.
There's no answer to my question.
Yes, exactly. I'm proud of it too. No, I'm kidding. Well, that part. So I really think that one of the excitement about this field, which I think should be a collective effort to find a good name, is that actually we really, I feel it like a collaboration, both in taking really a unified approach to what promises to be a fantastic scientific field, which is going to keep occupied for a long time to come. I don't want to say about the price of anarchy, which I love it. I hope that long live the price of anarchy, because I believe that it can be reincarnated if you take in essence on many other, can be repeated a similarly meaningful question many times. I really believe that we have to focus on bridging gaps that we have in isolated discipline to create a joint discipline. And there are a lot of things that we can do together which were not done before and do not belong to any one of us in particular. So I'd like to say this for starters and pass on.
All right. Well, in the interest of being controversial and speaking to the topic of future directions in algorithmic game theory, I'd like to speak to the elephant in the room in our field, which is that we explore the implications of models that we believe are not true. And I think this is a real problem for our discipline, as distinct from most other disciplines in computer science, that the kind of bedrock assumptions that we work with are assumptions that we don't actually think work, and not just in a small way. We really believe that the rationality assumptions, the omniscience kind of assumptions that it takes to make game theory work are wrong pretty profoundly. And I say this recognizing that in certain senses these are very reasonable assumptions to make, and they're very hard to avoid. A lot of very smart people have thought for a long time about ways of relaxing these kinds of assumptions, and you get into either very ambiguous or very dangerous terrain when you try to do that. So I think we have good reason for proceeding as we do. And I think also the questions that this discipline is concerned with are fundamentally very important questions that people care about. And I think that's the main reason why this discipline is important and why I care about being part of it, because I think we study things that are really important. So as a result, I think the progress will be incremental and will happen over a long period of time, and we need to be reconciled to the fact that we're going to spend our time working with assumptions that, in some sense, we're going to know don't make sense. Nevertheless, I think the danger for us is that we become kind of a priesthood that studies this orthodoxy of assumptions from 50 years ago in game theory, sort of enjoying the mathematical properties thereof without really thinking carefully about the extent to which these things describe the world. I guess I see two ways forward that I hope the field will adopt in the next decade. Of course, to some extent the field has adopted these directions already, but I think they're important. The first is to make an effort to encourage work that incrementally improves our models to make them more accurately reflect reality. So I think it's clearly the case that we can't, in one giant step, make everything perfect. But I think it's important to, when working in a particular area, consider the assumption that you find the most egregious about that area and think about ways of changing that assumption to make it less egregious. I think we've seen some beautiful examples of that kind of approach in the talks already in this workshop. I know we'll see more. I think on the purely kind of theoretical side, that's a really good way to go. Another thing that I think is very important for us, the second kind of direction, is that I think we need to become more grounded in data, which I think provides checks and balances on the theory. It gives us a way of saying that the theory has gone into a cul-de-sac, which is beautiful mathematically, but has stopped being useful in terms of getting traction on reality. So I think we need to be concerned with the actual behavior of people when we claim that we're describing people. I think we need to be concerned with real application areas and with speaking to people who really are experts in those application areas. And I think we especially should be concerned with things that really happen on the internet, because I think many of us in the motivation slides of our talks talk about how our discipline is great for understanding the internet. And for now, I think that's been useful hype for our discipline, but I think we're going to need to back it up with reality over time if we want this to keep working for the funding agencies round after round. Just to close my provocative remarks, I'll say that, at least in some sense, I think computer science is an engineering discipline, meaning that I think computer scientists are really interested in understanding how to build things that work for solving certain kinds of problems. And I think the place where I'll believe that our discipline is in really kind of solid foundation is when we really are able to make concrete recommendations about how to build systems that practitioners are willing to listen to and trust as, in fact, giving them good advice about how to build their systems. I think at this point we can say a lot of concrete things, but I'm not sure we're quite at the point where practitioners are particularly listening to us. And I think with that, I'll pass off to Eva.
Controversial things, so I'll just be boring, and then we can declare that we had enough and we are all free to go home or something. I definitely have to defend the. So first of all, Noam didn't say that algorithmic game theory. Oh, what am I supposed to do about this? Okay, now it's better. Sorry, I have to hold the mic really close. Okay, so first of all, Noam didn't say that price of energy is dead, but I have a laptop here, so I don't know what Noam said. Noam can defend himself if he wants to, but step number one of his defense, remember what talk he gave just an hour ago? It was a price of energy talk. Okay, Noam, you want to say what, you remember what you said? Yeah.
I just want to clarify. I did not say that. I said that the type of analysis that we compare what happens without incentive constraints to those with incentive constraints, that is alive and is going to be alive. That's the fact that we compare. Just the name I thought was being overused and is getting out of favor. So I prefer the way that Christos Papadimitriou talks about it as a third compromise. First, we looked at the compromise, what does computational, the fact that you need to do it computationally efficiently lose you. Then the second compromise is about online. What do we lose by doing things online? And this is the third compromise that we need to understand. What do we lose by the game theoretic notions? So this is very much alive. So part of my my lack of ease with the name Price of Anarchy, if you looked at my slides, I wrote Price of Anarchy in small parentheses, while my title was Approximate Welfare Theorem.
Okay. So I guess I'm not, I agree that algorithmic game theory is somewhat a misnomer. It's full with stuff that's not algorithmic. And Price of Energy might be an awkward name too. But the topic of comparing to the optimum, I think there's a lot of interesting things to do. One, sort of the easy question, or more obvious question, not necessarily the answer is easy, of taking a natural monism and say whether it's good or bad. Some of the natural monisms have been analyzed, and maybe there are some other options out there, but maybe not. And maybe we're going to have to merge it with monism design in a way. That is, it isn't going to be the most obvious monism, and maybe Noam's talk is an exception. That was a pre-natural monism, but have to do a merge between, monisms that are not truthful and where you can analyze only Nashes, but hopefully the Nashes are all good, and then it's sort of a good monism. So I guess I most would propose a direction that I think Noam's talk is a step in that direction, is a merge or a halfway between mechanism design and price of energy that is designing simple, elegant mechanisms where they're not necessarily truthful, but they generate reasonable outcomes. There are many, many issues in this sort of different or lighter weight mechanism design. I very much like the prior free mechanism design, whose name I think coming from the Tim and Jason paper. I hope, if not, then someone should correct me. That is, they want to do mechanism design where traditional mechanism design assumes we know a lot about the input distribution, and prior free mechanism design wants to not make that assumption and willing to compromise optimality at the expense of not knowing the prior. There are many other such compromises. We want simpler mechanisms. We want more implementable mechanisms. This one is nice because it's mathematically well phrased, but there are many compromises of this sort. And each of them we want to analyze the way Noam faced it, maybe not calling it price of energy, I don't know, I don't care, but comparing to an optimum without this restriction to whatever you get in this mechanism. And I think that there are a lot of interesting directions, and I think it's not dead, and hopefully Noam didn't mean it, even if his phrasing might not have been the most fortunate. Sorry. So that's one. I guess I had to defend the misquotes. Another fuzzy question. I'm not good at I like the Sergio question in the beginning. I'm not good at these very precisely stated questions. But here is a sort of a fuzzier question. So there is complexity. There is equilibrium are hard to find. And what on earth does this mean for us? And maybe many of you in the audience, or maybe even some people on the panel, but especially people in the audience, have thought more about what it means. But I think I want to most think about is that somehow so the mechanism that arised in the world, apparently we find something. Maybe we find the equilibrium, I don't know. Maybe the explanation is that we're not playing these worst case games, that maybe market prices are hard to decide, or maybe market prices are piece-based part to compute whether they exist or not. And yet you go to the store and there's some prices and life seems to be okay. So maybe if you make the right assumptions of how markets evolved or how mechanisms evolved, that leads to mechanisms in which computing the equilibrium is easy. I can't make any mathematical sense from this, but at the slightly more mathematical level, this is a two-stage game in which the mechanism itself is a result of some kind of game playing. And not being able to solve it possibly contributes to its usefulness. I'm not really sure how to phrase this. But I think there are good questions of this sort that I actually heard Christos raise many, many years ago in his paper of how networks evolve, and whatever the title was. The one I quoted. Yeah, something like that. But somehow beyond that Christos paper, I'm not aware of a large community of us pursuing this direction, and I still think it's an excellent direction and we should pursue this. I think there are interesting things in that direction. So maybe these were my two favorite things. And I guess since there are many of you in the audience who probably have thoughts beyond what we have, I don't know what Vijay's plan is, but we certainly can let the audience suggest directions. I don't think that. Oh, Sergio didn't get a chance. Sure. Definitely.
I mean, I didn't get a second chance. Yes. Okay, so it's clear that I'm an outsider in this community. On the other hand, I've been observing this community for a few years, as it keeps growing and changing. So first of all, I agree with Silvio. Algorithmic game theory is a very bad name. But you are in good company. Game theory is a very bad name. So, but trying to change it at this stage, I think it's hopeless, even though some people are trying. Ehud Kalai, for example, is trying to change this game sciences or other things. No, game theory is going to stay. So, I don't know about algorithm, but it's true. It sends a wrong message, but I don't know. Now, some real comments now. As I said, I've been observing the connections between computer science and game theory and economics and so on throughout the years. So it's quite interesting. There are many touching points Started probably with things on computability and logic. I think even Micali wrote one of the first papers on that, no? If I remember correctly. Yes, first, okay. But that's even before my time, so... then I think there is another connection which went through epistemology, and which I don't even think it is represented here at all. Knowledge, interactive knowledge, and all these things. Then again, the things about computation and automata and computing equilibrium and so on, and now all this boom on incentives and mechanisms and so on. Now, I should say, Noam, adding incentives, you don't lose, you gain. Okay? So in fact, just when you are talking about this price of anarchy, does it make sense or not? In fact, what do I care about optimum without incentives? You are never going to go there. So who cares? Why do you compare it with it? What you should compare is what the result is with incentives, because people and participants have incentives. That is the right outcome. The fact that there is some ideal point that may be reached in a dictatorial system, it never works. This has been tried. It didn't work in a centralized system where this is dictated from above what the outcome should be, and that's your benchmark. Okay, you can compare, but I'm not sure it's such a good comparison. So maybe that's a reason to let this slowly die. I don't know. Okay, so now another thing that I've seen, and I think it's something that I have, again, as an outsider, I have a slight problem with what is done here. I'm going to be... now, it's true that it's getting better, but it's still not where I think it should be. Game theory is a very precise discipline. So things are extremely well defined, and when one says a theorem, I can exactly understand what the theorem says. I may not understand the proof. When I hear a result in computer science, I am always a little fuzzy about what exactly the model is, what exactly the result is, what is it exactly about, okay? And I have to keep asking, and then sometimes I realize it's not what I thought, it's completely different, or that sometimes it's not even that. Now, as I said, this thing is getting better, but I must tell you that a few years ago, well, I spent almost 1 week with a very respected computer scientist trying to understand a result in computer science that has to do, an important result that has to do with game theory, and to translate it exactly to game theory. So there was this, oh, of course, this implies that, and you can do that. Okay, let's see what it is. After 1 week of, then the kind of thing I would hear is, okay, look, that's a problem. No, we reduce it to this problem, which we reduce it to this problem, and since we know that the problem 10 steps removes is this way, but maybe on the way you are losing something, you are losing some incentives here, so let's get a precise theorem. Well, after 1 week we gave up. We could not get a precise result that can be used in game theory. Even I suspect there is probably one there, it's even an important result, but I still don't know what that is, okay? I am very controversial. I mean, you are all very, very mild. Okay. No, it doesn't matter. No. I'll tell you if you want. It's not a reflection. It's a reflection on the dialogue between the disciplines. That's all. Okay. As you said, I thought that yesterday when I asked the question, it was crystal clear to me, but nobody understood it, so I had to rephrase it. So one is to adapt the languages. Sorry?
But Sergio, this is completely symmetric. When many years ago, I started to go to econ seminars at Cornell. I'm not as persistent as you, and usually after 1 or 2 questions, I stop asking. But I quite often get lost after 1 or 2 questions when I couldn't understand the answer to my question either. I just give up. I couldn't understand it. And yes, it's getting better. But I think you and I are getting better. You are getting better at understanding the other field.
Yeah. No. Sorry. You are right. I mean, there is the question is really the language and the translation between the disciplines and the connections. And as I say, this is getting better. It's on both sides. It's not an asymmetric statement. I'm sorry if I made it sound this way. Of course, because I'm asymmetric. So, okay. Now another theme that was here, that Kevin mentioned. There is really here a question about what is one doing? Where is one trying to go? Are we really trying to solve the world, or are we trying to really understand things? Now that's my personal view, yes? I am much more happy to get a beautiful insight into something. Whether that insight is immediately translatable into something practical that tomorrow one can sell to Google for its next auction on the sidebar or something like this, okay, I mean, that's important, and that's of course a justification of something that we say, but part of it is still trying to understand, trying to get the inside understanding of what really drives what. Now for this, you sometimes make assumptions which are indeed ideal. Okay, so one assumes rationality, but of course, by now we know that we assume bounded rationality, we assume less than full rationality, and in fact, much of game theory today is very far from full rationality. Much of it is very, very bounded rationality, heuristics, dynamics, automata. You heard things here. So it's true. There is some idealistic point there, but again, we have to understand what drives what. So we have to make assumptions and then see where we're going. So from here, going to real world, going to predictions, you know, there is still a big distance. When you can do that, it's very good. But I think that one needs a little more understanding before one can go there. In many areas. In some areas, one can go there very fast, yes? So maybe one doesn't need much. But that's what I feel. There are those two things. They go in parallel, but one should not forget that we're also trying to understand things. Okay. Now you can shout.
Okay.
In firing you up, did I succeed in firing you up?
Yeah. So he's elevating the bar. So before we go into the stratosphere, I just want to mention that there are indeed a few directions, namely having benchmarks, a bigger target for success that we need to compare a mechanism and say it's better than other. Privacy, as Michael put at the beginning, because if privacy disagrees with being truthful, who wins when it's not clear. So in general, you know, we need a new solution concepts, and the whole thing ought to be more robust, right? I mean, equilibrium is really, without any adjective, to me in particular, does not have much meaning. So if you put the right adjective, starting with, say, dominant strategy in front of it, then it's a different story. But otherwise, without adjectives, I really don't see why we are so enamored with this notion, which has no robustness whatsoever. But nonetheless, so we have to start from somewhere. So we have to recognize that if we are here, is because that was a successful path, and we should not spit on the dish from which we eat. Okay. So that's said, but we certainly want to go beyond. Having said something which, you know, hopefully is not controversial, just because we have to indicate perhaps some direction, maybe was whatever you had in mind. So I want to say that meaningfulness is rooted in ambiguity, to answer your question. Because the moment in which we understand something is passé, is over, is done, is not on a thing. So I really believe that you and I, we really understand, because any word that I say, you reinterpret on the other hand, with different meaning of what I mean, right? If I say this table is blue, I mean, if I read is blue, is the blue of the sea, Sicily, whatever, no, to me has some psychological connotation. When you understand the table is blue, not because if I really communicate the true blue, we will not understand each other. So I believe that any time that we want to get at something important, ambiguity of our language is crucial. And we should embrace it rather than rejecting and say that is not is good enough. Eventually, everything is going to become to the norm, we all be dead, and there is no oscillations of our molecules. We are in 0 Kelvin. That is not where the action is. The action is really the ambiguity. The other thing that I want to disagree with, because I have to pick up also on my left, not only on the right, so conveniently located, is to say I really reject. That's me personally. I don't think it should be a statement. At least I want to communicate to you how much I reject that we go for practitioner to figure out what we should do. That's the last thing that I want to do, period. Also because the so-called practitioners, to hammer everything is a nail. If they know nail, that's what I want to do. So I saw this beautiful movie, which the oldest one among you have seen it too, perhaps, The Gods Must Be Crazy. Have you ever seen it? Somebody froze from an helicopter, the Coca-Cola bottle, and this Coca-Cola bottle became the instrument that was doing magic things. Why? Because they knew and had the Coca-Cola bottle. All right? So people use what they know. And our really best contribution we can give to practitioners is to enlarge what they know, to give them a larger horizon than the confines of sniffing like dogs with a nose on the ground. I think we have failed as theoreticians if that's what we want to do. Once in a while, yes, we're going to have a check mark of how do we compare with what people do they understand the thing, but I think to have 25, 50 years lag time between what we do and what is going to get practical is just about right, I think. If we want to be really relevant, right? If you want, the other thing is to come to an understanding that if we believe that the fundamental theorem is the one that people rush from this door and start applying, we have to go back to school, starting elementary grade, right? So first grade. Because what people apply is an intellectual framework. Nobody applies a theorem unless you start giving different meaning to any concept in the theorem, and then you prove that by migrating it becomes something meaningful. Because theorems are not meaningful. It is a broad approach. That's what, it is a conceptual framework. That's what we really apply. And I think that we should really be very developing cogent and intellectual frameworks, and we should not shoot at the practical theorems. That is a bad direction, in my opinion.
How can I resist? It seems to me that the kinds of questions that we purport to study are very applied questions. We say things like, what is the way that somebody should sell a single good if they want to maximize the amount of revenue that they'll get? This isn't a question about number theory. This is a question about selling something to another person in exchange for money. And if the person who, in fact, has a thing to sell in exchange for money, who wants to maximize the amount of money that they get, finds the things that we say not to be particularly relevant to the thing that they're trying to do, we can dismiss it once or twice. I don't think we should be absolutely tied to the practitioners. I don't think we should be nothing but consultants. But I think at some point this should begin to worry us, that these people who actually have money on the line, who actually are solving the problems that we say we're studying, don't do the things that we say they should do, that we say are optimal for them. I think we should become curious about why this is. And maybe it's a failure to market our wonderful approach, and we should think about how to do that better. Maybe the thing that we're really doing is not the thing we say we're doing, and we should motivate our work differently. Or maybe we're missing something in our models which the practitioners recognize, and we should pay attention to that if we care about the problems that we say that we care about.
Can I make a statement about that, if I'm allowed to? I was just talking to Michael during the break, and he told me how there was a meeting of finite state automata work where Michael did some of the very first ones. And he told me how he moved out of it fast to move into other areas and changing all the time. But there were people his age who were still doing finite state automata. And I think what I want to say is that there is a trade-off between just sticking to your old stuff and going on and on and on in it versus going on to new ideas which are realistic and studying them for their own sake. And the reason we are doing game theory and not automata theory, because that's beaten up. And here we have new ideas to look for. It doesn't matter if somebody takes this idea and applies it or not. I completely agree with Silvio that we have to build the big picture, and we just have to provide the guidelines. We don't have to start a Mao-type cultural revolution where everybody goes into the paddy field and starts digging up. We have to be maintaining our intellectual integrity and keep doing new ideas, new things all the time.
Can people not say things?
Yes, it's a good idea. You have to use the mic, Robert. You get paid also, not just us.
So I wanted to address Silvio's recent statement and back up Kevin a little bit. And the way I wanted to address that was to suggest that, many of us in computer science have come through a fairly traditional computer science training where if you probably implemented an algorithm, you probably ran the algorithm at least once in your life. And you know, we've moved on to apply tools and techniques from algorithms to economic scenarios, for instance, like mechanism design. And how many of us have ever run a mechanism once in a real setting? And so I just want to point out that we've gotten some experience doing real stuff, and we've algorithm design, implementing them, and we've drawn from the experience of our field in creating a field of algorithms that was relevant. And I don't feel like just adopting, without thinking about it, the tenets of algorithm design and applying them to mechanisms is going to be the right way to get a field of mechanism design that's relevant. And so some attention to the practice before we, you know, pursue headlong into building a field of algorithmic mechanism design is definitely warranted.
Okay, so I
Or at least needs to be renamed.
Okay, I guess I wanted to second Kevin too, and I figured that, you know, poor Kevin here in the, you know, more applied end of our field is coming out saying that we should all be more applied. And I appreciate that there's a spread, and it's nice to have people who are more applied than people who are less applied. But in some way, I, for example, actually have a mathematics training. I have mathematics, all my degrees are mathematics. But for some reason, I chose to switch to this field. And actually, the reason was because it seemed relevant. And if you don't keep it relevant, it's going to have to become a field of maths, which is okay. But somehow, I think we have to choose. And I clearly chose at some point, and I want to choose the same thing again. We better keep this damn thing relevant. Whether we do it by implementing things or whether we do it by talking to practitioners. And I don't mean all of us have to do it. And it doesn't mean that we don't have to do things that are sort of seem to be basic things and the practitioners today are not interested. But as a field, we need to do enough of this so what we do is grounded, because otherwise it's supposed to become a subfield of mathematics.
So I sort of want to slightly support Silvio, but end this with a question to Silvio. So I have to admit that Kevin's question is really the one that was always really bugging me. How do we know that we're not turning into this, you know, closed group that are like improving each other's theorems and definitions and no one cares, which is something that happens very easily to lots of scientific disciplines. And the question is, how can we avoid it? And so one possibility is actually to be more practical, and then you get some sense of reality. I think that the problem is, in this field in general, that we always need to look forward. In the sense, the difference from us in philosophy, between us and economists, is that economists really are interested in the world as it is. They want to understand it. They want to understand what's going on. This is not our point of view. We're engineers. We want to design new things. To design new things, you have to be ahead of the curve. You have to invent something today that is not yet practical, does not apply to anything that currently is out there. If you tie too much to what now happens in Google, for example, as opposed to what could be in Google in 5 or 10 years, then you're missing the point. So in this situation, there is a delicate balance here. You can't listen to practitioners. You have to define the new concepts. Of course, you have to keep in your back of your mind that we're trying to do things that can be at the end implemented. And in this, I think that we're really different philosophically from economists rather than from practitioners, because really we're thinking about new things. Now, that does leave a little question of what's our checks and balances? How do we know that it's not going nowhere? So, for example, I remember theoretical cryptography of the 80s and 90s, and as opposed to the very early cryptography, which was very obviously applied, so I remember Michael Rabin always implemented his theorems, actually, as cryptography of the 80s and 90s, to me, seemed extremely theoretical and completely unapplied. It took 10 more years only until it was all the time applied, and the internet is actually based on that. So it's very difficult to know whether you're going into some correct direction or incorrect direction. And that's, I think, the main good thing about panels. This is like a chance for the community to try to do this kind of reflection. Are we going in reasonable directions? And I think the question is still difficult. But we can't go too quickly to practitioners. We have to go and think about things that are not yet practical in any sense. It's currently no one is willing to listen to us. Otherwise, we're not doing our job as theorists. But ending with a question to Silvio is, so how would you, and actually to Eva, who's a theoretician, so how do you suppose to actually, what will be our checks and balances? Should we just trust our good scientific taste and have these panels to keep us in line, or there is some other mechanism?
Well, first of all, I think that we have been, the audiences start becoming reasonable, so we must be doing something right by being outrageous over here, right? So that is good. So before taking your question, which really I would like to avoid, but I'll give it a chance, I want to say to Kevin, right? Because when I believe that the trick in doing anything that changes is to use old words, right? And you say mass, Newtonian mass, Einsteinian mass. Yeah, it's mass, right? I mean, you don't pay attention that under the covers things have shifted, right? But that's how you actually, again, with ambiguity, you get understood. You use an older terminology. So very often, yes, indeed, we use auctions as a metaphor. But actually, what we are selling is new stuff, because otherwise, there is so many auctions that we can do, and we are covering all over the space. And when you say about maximize, that is exactly the point. Because the moment in which you start maximizing means that there is already a direction that it should be clear what it is, and in that direction are we getting the optimum, right? And instead, personally, for instance, I believe that it's not clear at all what we should maximize. The traditional temptation is to maximize the pie in the sky, this mysterious optimal revenue, or whatever it is, that sits out there and nobody can get at, right? And then, we get very frustrated because we cannot get at it. So I really believe, at least selfishly, if I can steal a point, that it makes sense, something that at least we are doing with Jing, to say in a combinatorial auction, benchmark against how the best informed player could sell the goods. Not an hypothetical, to go back to your question, how could you really make, by assigning, by magic, these things? Who knows? Benchmark against the players. The players know each other better than we do know them. Benchmark against them, against the knowledge that they have each other. Right? So the point, when I see the word maximize, what I don't buy is what direction. It's very easy to say maximize. Right? But Jason has his own very defendable notion of maximization. It's in a different direction, right? So each one can actually come up with a better one, and it's hard to predict now which one is going to really be the winning one, right? But I think that really the fun is in the journey, right? So and I think we have to keep the ball in the air a little bit more and having a little bit more patience. But we see that at the end, my prediction is that whatever is going to end is not going to be the old pie in the sky. It's going to be some of these new benchmarks that we are so eloquently creating and convincingly creating, and one of this is going to gel, or maybe even two, and we start seeing that this is going to come up in practice.
Yes. So as far as what is the measure of success of a theory without going to practitioners, I think it is whether or not it hits other theories somehow. I mean, when you do something foundational, the theory meets up with another theory and becomes a bigger thing. And whether you did something foundational or not comes from that. And there are many, many examples throughout ages, when non-Euclidean geometries were studied and they had impact on the theory of relativity and so on. So these are ideas that were really foundational and grew into other theories and made an impact. So in our own little way, already things have happened from algorithmic game theory back into complexity theory and algorithms, and these are beautiful insights and new chapters in the theory of algorithms itself that have happened. And I think we are very proud of that.
Hello, just want to mention one thing, if possible. Just want to mention that this is not the first time that these questions of relevancy are rising in computer science. I mean, for many, many years you are considering the worst case measure, which is very, I mean, everyone here, most people are considering this measure, and this is, you know, it's not necessarily the best measure. For example, if you are talking about, let's say, a traveling salesman problem, which is used many, many times in practice. I mean, we have a 1.5 approximation algorithm and maybe now 1.499. And if you take any practitioner, he would never use this algorithm because he can get 1.001. So, I mean, and we consider all these approximation algorithms that we work for the last 20, 25, 30 years as a success. So, I mean, it's very hard to actually understand what's, why we consider, I mean, if success is really related so much to practitioners, I mean, directly. I mean, it's more like the ideas and what do you understand out of it and not necessarily direct application.
So I think I want to repeat that I think direct applications do matter. At the end, we're theoreticians, and we don't want to be like consultants or whatever. So theories is not. It's still not. Did that help? I turned it on and off. Okay. So I think theories, of course, matter, and connecting to other theories has a potential. I don't think. If I want to, maybe I should actually just start by directly addressing Noam's question. I don't think these panels do anything to evaluate this kind of things. They possibly do something to suggest some directions that maybe some of you will think that, oh, that's actually cool, and let me work on this. And certainly survey talks, like I guess in whenever there was 2002 or something, when Christos gave us a talk, was it 2002? At some number like that at Stock, that was, I think, incredibly influential in convincing a lot of people to work on this. So panels can do that too in convincing people to work on certain things. I think the peer reviewing is what takes care of the evaluation part. And I kind of think that everything should be grounded in something. Some of our fields should be grounded in more practical things and having an impact, and some of our fields should be grounded at creating a bigger theory that has the potential to have an impact later. And everyone should do some of these things. And we're all obliged to write an introduction to our paper that explains where our contribution lies and where we are grounded. And if we can't do that, then hopefully some panel or some refereeing process dealing with the paper will tell you to get lost. And as much as it's painful to listen when someone rejects your paper, or my paper, I think we should actually listen, because that is the process on which the field tries to sort out what are valuable contributions. And when I said that I want to second Kevin, I certainly didn't mean to say that all of us need to do this. The field as a whole, some of us need to do this. And some of us should need to do other things. And hopefully as a field, it remains healthy as it stays grounded in things. At least that's my proposed answer to Noam.
Is it on? So I'm going to be a little bit of a coward and a cop-out. Namely, I'm going to say that both, let's say, Kevin on the one hand and on the other side, Silvio and Noam are right. And I mean it in the following sense. Maybe roughly the contributions or the type of research in algorithmic game theory is divided into two directions. One is trying to explain and quantify observed economic phenomena like clearing of markets, creation of prices, etc. And when it comes to that, then certainly I think that being meaningful in the real world is essential. So, for example, I could say invent a law of gravitation where gravitation goes with distance like 1 over r to the 3 over 2 instead of square. Let's forget about Einstein for a moment. Then I can prove possibly beautiful theorems about planets moving in helical orbits around the sun. It's really going to be astounding and much more sophisticated than, you know, the proof by Newton that planets move in ellipses. But it's not going to be a real contribution. On the other hand, there is the facet or the side of algorithmic game theory of really designing, for example, new mechanisms. And their inventiveness, so you also make assumptions about designing a mechanism, optimizing, and I also agree with what you say, not a pie in the sky. In that sense, you really get closer to Kevin. You say you have to consider mechanisms where people have, you know, their own limited knowledge about the actual state and profits, etc., etc. So when you come to that, then one should be absolutely inventive. And then the question is somebody going to pick it up or not? And if nobody is going to pick it up, then this is sort of somebody who is screaming into an empty room. He can, or singing into an empty room. It can be a beautiful aria, but has no effect. So both sides of this equation, let's say, are, to my mind, completely valid. And some people will say that they want to somehow discover or find reasons as to how the world works. And then I think that the question of comparing it to how the world actually works, whether planets move in ellipses or helical, is very essential to the validity of what they do. And others want, say, to invent a very efficient way for a satellite carrying, you know, rocket to take off. How you say burn out the fuel there to get, you know, the best speed eventually. And this is where invention comes in. And it's being tested later on by its acceptability.
So I think that was very eloquently said. Even so, I guess I'd like to push back on what I see as a bit of a false dichotomy that we're being presented with here. And I don't mean particularly to say even that you exemplified that. But I think we're hearing a narrative here that on the one hand says, you know, our job is to build a beautiful abstract theory. You know, I may claim that I'm building a model about routing in networks, but don't take it so seriously. Really, it's poetry. You know, you should just love it because it's beautiful. Read it before you go to bed at night. It'll make you a better person. And on the other hand, we hear another narrative that says, you know, it's all about practitioners. You know, our job should be building faster web forms for Google that let people enter their address better. And clearly, there's got to be some kind of middle ground. I don't think really, you know, anybody, when pressed, is really going to say one or the other. I don't know. You might really defend the poetry. I'm not sure. But certainly that's not what I'm trying to say. I'm certainly not saying I think everyone in this field should become a practitioner. That would be, for one thing, it would mean that I would have to hate all of my own papers because none of them are about actually making real things happen in practice. Rather, I think our discipline is a somewhat applied discipline. It claims to make models of the world that give insight, and those models are imperfect, and so the insight is limited, but it's nevertheless useful. And we hope that our limited models tell us good things even though we know that they have limits. And I think there are two ways that we can make progress in this kind of narrative. The first way is by being really good at math and taking those same models and saying deeper things than we could say before. And I think that's great. I think that's a kind of contribution that many of the people who are here make, and I think it enriches the field, and it's a good thing to do. I think another kind of progress is made by finding new models that are closer to reality while still offering some kind of analytic traction. And I think as a whole, we have to see a certain amount of that happening in the field over time. We have to see this sort of realism potential function getting improved as time goes on. And that means that this whole kind of mathematical deepening kind of process is being applied to models that are more and more close to reality. And that's what I'd like to argue for. So Almas was waving his hand.
Yeah. Look, I think I want to say that this discussion, again, I'm an outsider, but I don't find this discussion, it sounds as if there is a big argument here. There is no argument here. I think, you know, science has its way of calibrating itself. And things become extremely theoretical and useless, they will die out. Okay? So I think that, you know, and different people do different things. Some people do things more applied. Some people get ideas from there. Some people do things more theoretical. And suddenly they come to a conference and they say, oh, that's exactly what you are talking is useful for my problem. So I don't see any dichotomy or any argument or something. The field is wide enough and everything goes. I mean, I don't know. As an outsider, I don't think one needs to say what to do.
I think, okay. Amos.
Yeah, okay, I just wanted to, I like the poetry issue. I mean, most of us forget that our major role is, you know, teaching. This is actually what we do. And we teach people, undergrads and grad students, and somehow we teach them things that we think are useful or maybe we think are fun. And then they go off and they do things in the real world. Some of them very successfully, right? So that's the interaction between us and the real world. It's not exactly that the papers, you know, you take a paper and it builds a bullet train. It doesn't work that way. But you talk about fun projects and games and stuff, and then students go off and build a bullet train or something else, and maybe things having to do with algorithmic game theory, maybe not. So this is really our role. Right? Most of us here are educators by definition. And I mean, some of us here are involved in Google and many other companies, and certainly have a major role there. But and then that they certainly have an impact in the real world. But it's not clear that it has anything to do with any specific paper they ever write. It probably doesn't. I mean, without knowing specifically what they're doing there.
Last one by Vince, and I think we should call it a day at the end of it. Vince wants to say something.
So I'm a little bit surprised that we're having this whole discussion so much in the abstract. So obviously I'm biased, but so meanwhile we have this group at the University of Southern California using algorithmic game theory in all sorts of security games. With potentially all US airports deploying an algorithm for solving games for doing their security. Is that not the kind of application that we're looking for? They're not students, they're a research group at the University of Southern California. Is that the kind of thing that if we're talking about having applications, is that the kind of thing that we're looking for, or is it somehow not? And if not, why not? So that's a big debate. So,
okay, I don't think
they apparently the only thing they've told me is that more people have been caught. Now you don't know for sure whether that's because security has become so much worse that many more people are trying.
So Vince, I don't think we needed another question to prolong the discussion, because I think people want to go to dinner, and it's great to hear that the spectrum is very wide and we're covering it very well. So I hope this was a useful discussion for all of you. Thank you.